Hello, everyone. This presentation will talk over my Capstone project for data 606. So my project topic is Amazon product recommending system. The entire presentation will cover several factors or sections in my project. So it will cover the project introduction, the research questions of this project, the data source I'm going to use, research process, and exploratory data analysis, and the machine learning models I'm going to build, and finally, the expected outcome from this project. So let's get started. Let's go over some project background or introduction. As e-commerce becomes more and more popular in recent years, especially by the impact of the COVID-19 pandemic, many retailers and companies are switching their business model to adapt to the trend. In addition, with the rapid growth of big data technology, the cost of storage to store numerous amount of data from customers and visitors on the e-commerce site decrease gradually. So no matter the tech giant or startup company, everyone can make use of the big data to boost their business success to the next level. So why recommending system is important in the current era? There are several benefits business can achieve using such a system. It can drive traffic through personalized email message to the store site and increase average order value. It also can enhance the shopping experience by delivering relevant content based on the personalized preference. It can reduce the workload for inventory management and boost work efficiency and effectiveness. It can create a comprehensive report to support making the right decision for business direction. Overall, product recommending system not only boost the company's revenue, but also increase customer satisfaction and loyalty. So the objective of this project is to analyze the reason for a product to be recommended and explore different data science methods and algorithms to implement product recommending systems. It will provide business owner or startup companies a better idea of how recommended system work and the related advantage. So the next step is to identify the research question for this project. So the research questions in my mind is to figure out what characteristics are useful to generate personalized recommendations, and also which recommendation system algorithms or methods are most useful and practical in the real world scenario. And also I would like to figure out, can textual data improve the recommender system's performance? Once we get the background and the research question, we will go over some data source I'm going to use for this project. The data for this project is the Amazon review data, which is collected by the University of California, San Diego. The data set includes both reviews data and the product metadata, and it contains a total number of 233.1 million view reviews with the size of 34 gigabytes from the Amazon website. So due to the computing resource limitation, a subset in appliance category will be used for this project. The reason why I chose the appliance subset for this project is that it has a moderate number of products and reviews. So it is a great representation of the entire data set and shows how the recommended system works. future study can leverage my report to the different product categories in this data set, or even apply it into the entire data set if they have sufficient computing resource. So for the data structure, the review data has a total of like over 600,000 review records in the appliance category. And the dataset has like 12 different features. The table below shows the features in this dataset and its corresponding data type and description. As you can see, it has the ID of the interviewer, the ID of the product, the name of the reviewer, helpful roles of the review, dictionary of the product metadata, the text of the review, the rating of the product, the summary of the review, and the review time, and image and review if the review is verified. So among all those features, the interest feature will be the overall rating of the product, the review time, the review ID, the async number, which is the product ID, the review test, and the review summary. For the product data, there are a total of over 30,000 product records in this category, and the dataset has 19 different features. As you can see, the data contains an ID of the product, the name of the product, the features of the product, description of the product, the price, the image, the sales rank, the brand name, the categories, the technical detail of the product and the similar product, and size and related product of the existing one, and main category and the release date. So among all those features, the interest feature will be used for this project will be the category, description, title, brand, feature, main category, product release date, price, async number, and image. So now let's talk about the research process for this project. The goal for this project is to develop a system recommending system. So the first step will be collecting the data, which already defined in the previous slides. The next step will be performing an initial EDA to clean or transform the data and prepare the data for models development. So the next step will be developing our machine learning models. And finally, once we have our model complete and trained, we would like to deploy our model into a web system for integration. So the user can make use of the recommending system to guide their purchase decision. So this slide will talk more detail about each step. In the phase 1, we will collect necessary data for the recommending system. And the next step will be the EDA, which discover some insights of the data set and do the necessary data transformation for ML models. And the next step will be building our ML models. We will apply two methods to develop our recommending system, which are content-based filtering models and collaborative filtering model. And finally, we will also develop a hybrid model based on these two different models. And finally, I will build a website and a chatbot to interact with the user and provide a list of recommendations for user interface. Okay, let's go over some exploratory data analysis for the project and discover some insight of the data set. Let's get started with the review data. The weighting, these two graphs shows the weighting distribution. The weighting distribution graph shows that the overall weighting in this review data set are highly imbalanced, which contains like 69% of 5-star rating. So in the following model development, we'll need to keep in mind that the accuracy matrix might not be useful for evaluating the machine learning models. Instead, position we call F1 score value might be suitable for model evaluation. And this table shows the review count and also how many reviews they provide in the data set. So there are a total of the 515,650 distinct reviewers in this data set. And the most active reviewer have reviewed like 208 products with an average score of 4.98, which means this reviewer pretty much have provide high score rating for every product they he purchased. This table shows the review year distribution in this data set. So this graph shows the reviews in this data set are highly or heavily collected after the year 2013, which can quite well represent the current generation's customers' preference. So the recommending system we develop will pretty well represent the current generation customer. The next graph is the review month distribution, and it shows that the months are quite evenly distributed in the data set, which we can conclude that the season doesn't play a significant role in the influence of the purchase of the appliances. This graph shows the more detail about the review test data. So most of the reviews contains less than 100 rows. It's like 98%, over 98% of the review contain less than 100 rows. The row count distribution for each star rating review are similar. The box plots show that the 5-star rating reviews has the lowest IQR compared to the other 4 rating, which implies that it has averaged the shortest review test. So the next slide will do some EDA against the product data. These two graphs shows that the majority of the product are in the tool and home improvement category, and the appliance category also hold like 21.5%, whereas the home improvements holds like 64.6%. And the graph on the right side shows the product brand distribution. So there are a total of 2,762 brands in this data set, and Whirlpool is at the top 1 position of the amount of the product. And in this table is the list of the ranking of the most reviewed product and the average rating. Among all the appliance products, there are only like 30,000 to 52 products are reviewed. And the the graph on the left shows that the most reviewed product is the General Electric MWF refrigerator water filter. And the second most reviewed product is also the water filter, which is the Samsung new refrigerator water filter. And this two tables shows the test distribution, the product test description, work count distribution. The product test histogram and box plot show that the majority of the product test is less than 1,000 words. So there are only a few outliers that are greater than 2,000 words. So for future NLP model development, in order to reduce the padding size, we can consider a smaller number instead. In addition, I have created a workout against the product data, and this picture shows that the most frequently used role for appliance products are related to the replacement part and model number. So this slide is the EDA against the merged data. To find more insights within this dataset, you can merge the clean review and product datasets. Most reviewed brand distribution top 10 shows that the Whirlpool product has the rank 1 position of the amount of the review. However, there are some other brands in the list that are not in the list of the top 10 product numbers, which means offering more products doesn't imply more purchasing and revenue. In addition, this table shows the top 10 average rating brand, which has the review number greater than 5,000 in the dataset. The result show that the brand either has the highest average rating, like 4.62 with over 6,000 reviews, whereas Whirlpool has the rank 4 in this list. So it pretty much tells that Whirlpool is doing great in offering both overall product quality and quantity. Now let's go over some machine learning models for this project. We are going to build both collaborative filtering and content-based filtering recommending system. For the content-based filtering, I plan to use the cosine similarity model. Against the product metadata to identify the similar products for the given one. The main feature that will be used for this model is from the product metadata like description, price, sales rank, brand, categories, and product features. Since some of them are textual data, NLP technique like tokenization, TF-IDF will be applied. For the collaborative filtering, I will apply the matrix factorization method against the review data. The main feature that will be used for this approach is from the review data like user ID, product ID, and the rating score. To perform matrix analysis, the cosine similarity method could also be used again, and several other machine learning algorithms will be used, such as KNN, SVD. KNN can group user into a cluster and only consider the same cluster user for product recommendation. SVD can break down a matrix into the product of filter smaller matrix to review the user connection and discover the relationship between products. Moreover, deep learning technique could also be applied for the collaborating filtering. Neutral network method can take the user item matrix or the review textual data for predicting a score for recommending. So the above two types of filtering have their own drawbacks, such as the novelty problem of the content-based filtering and the co-star problem of the collaborative filtering. So in reality, more robust recommendation system like a hybrid recommender are often used. I plan to build a hybrid recommender that combines both of these two models to overcome the drawbacks and improve overall performance. Finally, for the recommendation system integration and deployment, I will develop a user interface for that better using experience. I will develop a Flask website and use Python Anywhere web hosting server to host our recommendation system. Next, I will develop a chatbot using Dialogflow platform to assist user for product recommendation and integrate with the Flask website. This is the Flask web application prototype for the project. It contains a chatbot on the homepage, which developed by using the Dialogflow platform. The website is using Google API to send and receive a message from the Dialog platform and display them on the chat box on the web page. Since our machine learning model are not developed yet, the chatbot now can only handle some simple conversation and couldn't provide any product recommendation. Finally, the expected outcome from this project. I intend to achieve through this project is to develop a product recommending system or models that can accurately predict customers' preference. Besides, I would like to achieve is it can identify the most useful characteristic to promote certain product to customer. Understand the role of the textual data in the recommending system, provide a website and chatbot to assist Amazon user to make purchase decision. Finally, to provide a comprehensive report of recommending system for the business owners. And this is the list of my current reference resource. Thank you so much.